Hi, today we will discuss on chapter number 5, Introduction and Basic Concept of Thermodynamics. Okay, what is thermodynamics? Thermodynamics is taken from the Greek term called therm. Therm means heat and dynamis means power. Okay, so if you combine, it will actually discussing about the science of energy. Okay, so thermodynamics is the science that deals with heat and work. So there are two things, heat and also work. So heat is something related with temperature change. If the work is not related to temperature, it is considered as work. And those properties of matters that relate to heat and work. So all these studies are related to thermodynamics. Okay, so when we say about thermodynamics, there are two names that we always will remember. First one is Lord Kelvin. Okay, so it's coming from the temperature term Kelvin. Okay, so he first used the word thermodynamics in 1849, and we have William Rankine. Okay, another person called William Rankine. So he came up with the first thermodynamic textbook, which was written in 1859. Okay, what thermodynamic law is saying? Okay, the first thing is the conservation of energy. Okay, so energy can change from one form to another form but cannot be created or destroyed. It's something that we know. Okay, so energy only can change form but it cannot be created or destroyed. It is something that happen naturally in the universe. Okay, and the second one is the first law of thermodynamics. Okay, so it's an expression of the conservation of energy as a thermodynamic property. So using the first law of thermodynamics, so you are actually measuring the conservation of energy, okay, or you are trying to define it as a thermodynamic property. So we will see this later. And we have a second law of thermodynamics, so which says that energy has quality as well as quantity. So it's not only related to quantity which can be measured, but the energy also have a quality. And the energy transfer will always occur in the direction of decreasing quality of energy. So what is decreasing quality of energy? As you can see here, so we have a cup of hot coffee, so which is 70 degrees Celsius. So we consider this as a high temperature. Okay, and we have a cool environment in the surrounding with 20 degrees Celsius. So what will happen for this hot coffee in the mug? After some time, naturally, this 70 degrees Celsius will be calibrated to 20 degrees Celsius because the surrounding is bigger, and it will move from the upstream, so which is the higher temperature. The heat will be released to the surrounding, which is a lower temperature. Okay, lower temperature, we call it as a downstream. So the heat flows in the direction of decreasing temperature. That is what we call as direction of decreasing quality. So you can increase from 20 to 70 using microwave, or you're using a stove. You introduce a new heat inside, then it can be increased, but it cannot happen naturally. So that is what we need to understand. So the study of thermodynamics can be divided into two, which we call as a macroscopic approach, and also we call macroscopic approach as classical thermodynamics. In classical thermodynamic or macroscopic approach, we does not require the knowledge of the behavior of the individual particle, meaning whatever things that happen in the molecules inside, so we are not really taking into consideration. So that is macro. Macro means is bigger scale, a bigger approach. Okay, so when we see with the naked eyes, we cannot see the particles. So that is a macroscopic view. So if microscopic, So it's similar like you are using a microscope. You want to see very small details inside. So microscopic approach, also we call it as a statistical thermodynamics. So we are concerned about the detailed knowledge of the behavior of individual particles. So we want to investigate how the molecules movement and the energy release because of the pollution. So we want to see the movement of the molecule or the atoms inside. Then we can call it as a microscopical approach. Micro means small, macro means big. Okay, we define the systems. Okay, so thermodynamics deals with systems. Okay, what is system? So whatever we want to study. Okay, so if we want to investigate something, we need to have a boundary. We need to have the system that we want to investigate. So system is whatever we want to study. The quantity of mass or region in space. So all can be considered as system. Okay, then in the system we have the surroundings. Surroundings is a mass or region outside of the system. Okay, so system is a place where we are investigating, and surrounding is something out of the system. And we have a boundary. So boundary is in between the system and also surrounding. So the area which is, it can be real or imaginary. It can be a physical one, or it can be something that we imagine, which is not available there. But we can use this imaginary surface to define our system. Okay, so it can also can be fixed or movable, shared by both system and also surrounding, no thickness, no mass, and volume. As you can see here. So we have a system. We have a system. This is the place that we want to do our investigation or studies, and we have a surrounding around it. And the place where the surrounding and the system meets, we call it as a boundary. So you can see the dotted lines here. So that is what we call as a boundary. Okay, so example, so we have a system. Okay, so uh, the water is what we consider as a system. We want to measure the pressures from point 1 to point 2, and we have, with increasing depth, we have more pressures in P2. So this is what we consider as a system, and we have a boundary on top which interface with the surrounding. So surrounding is the ambient air. So we have a surrounding. So surrounding is the normal air in our surrounding. So that we call as a surroundings. So system can also be considered as a closed or open system. What is closed system? Closed system means it's a control mesh. So the mesh inside we are controlling. So we have a system here. Uh, this is not. We have a surrounding outside, and we have a system. The system is the brown color. Okay, we have a gas inside the piston. So we have a boundary. Okay, as we say, all the system or the surrounding, we will have all three. We will have surrounding, we will have a system, and also we will have a boundary, whether it's imaginary or physical. Okay, so we have here a system that always contains the same matter. Meaning, in a control system, so the mass will not change. The mass is controlled. Meaning, if the piston moves up or down, the amount of gas particle inside will be the same. So the mass is controlled. Okay, so no transfer of mass across this boundary can occur. Meaning, if you want to investigate in a closed system, meaning the particle or the molecules inside must be the same. So it cannot be increasing or decreasing. So no transfer of mass across this boundary can occur. Okay, so heat or work can across. Okay, meaning it's energy, so it can cross the boundary. So meaning if you have a constant movement and the energy is transferred to it and it is releasing outside to the surrounding, it is possible in a closed system. Here we also have an isolated system. Isolated system is a special type of closed system that does not interact in any way with the surrounding. So meaning no energy crosses its boundary. So meaning no heat or work also crosses. So it's totally isolated from the surrounding. So no energy transfer. That is what we call as a. We also have an open system. Open system. So we control the volume. We control the volume is a region, a given region of space through which mass flows. So here the mass is not controlled. You only control the volume. So you can see here. So we have engineer. Okay, so we are air is in. We have a imaginary boundary. So boundary. So we call it as a control surface. So meaning here we this system, this is a system. This system is not expanding or shrinking. So what it happens when the drive shaft is rotating? So the gas is coming in and out. So meaning the mass is coming and going out. So that's why we call it as a control volume. So where the mass can go in and out. Similar, for example, we have a water heater in the house. Okay, water heater is close control volume. So meaning the water heater is not expanding or shrinking. It's a control volume, but water is coming in and going out. So the water is the mass. Mass is coming in and going out. Similar like here. So there's a movement. When there's a movement, there's a work done, and also there can be a heat generated. So the water or the fuel is coming in, and exhaust gas is going out. Okay, so you have a drive shaft and other stuff. This is a system. You have a surrounding, and there's a boundary. Okay, that is what we call as a control volume. Control volume, or we also can call it as a control surface. Meaning the surface area is not expanding. Okay, so mass may cross the boundary of the CV. CV is control volume. The boundary of CV is called control surface, real or imaginary. Okay, so you have a control surface. Normally we will write it, draw it as a dotted line. Okay, so property of a system. Yes, so what is property? So these are some of the terms that we always use in thermodynamics. The properties of a system means any measurable or observable characteristic of the substance and the system remain in equilibrium. So that is what we call as a property. I can show you some example. Okay, so what are the example? So pressure. Okay, we have a pressure, we have a volume, we have temperature, so mass, so viscosity, electric resistance, thermal conductivity, etc. So there are so many properties. So pressure is one property, okay, which we can measure from a system. The volume is another property. So temperature is another property. Whatever thing that we can measure in a value, that is what we call as a property. The property also can be divided into few. The first one is intensive. Intensive meaning is independent on mass of system. This is depend by the mass. Okay, so independent on the mass. So meaning it's not dependent. Okay, so whatever terms or whatever property that is not related to mass, so we call as a independent to mass or intensive property. So for example, like pressure, so we have an elevation, so it's not really related to mass. Then we call it as a intensive. Then we have extensive meaning is dependent on the mass. So like total mass, total volume. So when the mass changes, so all these values also changes. So that means it's a dependent. We call it as a extensive. Then we also have a specific volume, specific property. Then it specific means is per unit volume, per unit mass, meaning volume over mass, okay, so, enthalpy over mass, so which we call as a this is per unit mass. Normally per kg, normally will be per kg. So you can see here the same. Okay, what is a state? State is a set of properties. Okay, so earlier we saw what is properties. Here you have a set of properties. It completely describes the condition of a system. So normally when you have a system, okay, normally you won't have one or two properties, you will have more. It's like you can see here, mass, temperature, and also volume. So the first state, if it has few states, meaning when this is a starting initial state. Okay, starting state always refer as initial state. So a system will at least will have one state. Okay, so this is the first one. We call it as an initial state. So in initial state, M equals to 2 kg, T equals to 20 degrees Celsius. Volume is 1.5 meter cube. When one of the property changes, then another state is created. So here mass is the same, temperature also the same, but the volume changes. So meaning the system moves from state 1 to state 2. So the system, whatever system that we have, it can have more than one. It can have 5 or 6 states. Which depends on the system. Okay, so we also have a term called equilibrium. You can see here the few types of equilibrium. So equilibrium meaning a state of balance. There are no unbalanced potential or driving force within the system. Okay, so meaning if the system moves from one state to another state, and it can sustain without any interference, meaning it already reach a balance. Okay, so we have a thermal equilibrium, so meaning after some time, no temperature differences. Okay, no temperature, so the temperature between the system and the surrounding become uniform. So we also have a mechanical equilibrium, meaning no pressure gradient, so no differences in pressure. Okay, so we call it as a uniform pressure. We also have a phase equilibrium, so meaning system having more than one phase. So mass of each phase is the equilibrium, meaning the mass is not changing with various states. And we also have a chemical equilibrium, meaning no more chemical reaction in the system between state 1 and state 2. So no reaction occurs. That is what we call equilibrium. So all these are some of the terms that we use in thermodynamics. Okay, so there's another term called quasi. Quasi means almost. Okay, so at times in our investigation, we need to use this quasi. Okay, because quasi-equilibrium or quasi-static process, so the system remain practically in equilibrium at all times. So what it means, so if this piston, we have a piston here, if the piston move from 1 to 2 in a fast state, so you cannot measure a lot of stuff. So if you want to measure the differences between 1 and 2, so you need to move it slowly. So slow movement, which almost resemble, okay, or almost showing that it is a static process. Because normally, even in our daily life, when things are moving faster, we cannot really capture similar. So when you have a quasi-equilibrium, meaning it's almost equilibrium, so you can always assume that it is in an equilibrium state already, even though there are slow movement. Okay, the sufficiently slow process allows the system to adjust itself internally, so the properties in one part of the system does not change any faster. Okay, meaning when things are not really changing faster, so it will help us with our investigation. Okay, we study quasi-equilibrium processes because they are easy to analyze. So it's easier to analyze. Okay, and we also can apply equation of state. Okay, maybe for the gas or equation of state. Normally we apply for gas. So we also can apply other equations in order to measure to analyze. So slow compression we call it as quasi-equilibrium. A very fast compression we call as non-quasi-equilibrium, meaning it's not quasi-equilibrium. In most of the process that we will study on thermodynamic properties constant. Some of these are, you can see here, there are two graphs. If the graph is pressure to volume, if the graph is like this, meaning the volume is not changing, the volume is constant. So if the volume is constant, we call it as isochloric. These are some of the terms that can appear in the questions or in our analysis. Isochloric meaning so pressure there's a difference between point 1 and point 2. The volume is not changing. Then we also have constant pressure case, but the volume is changing from one point to another point. It's increasing or decreasing. Okay, so this point we call it as a isobaric. So isobaric means pressure is constant. Isochloric means volume is constant. Okay, then if the graph is temperature to enthalpy or entropy, we call it as a isentrop, isenthalpic. Is enthalpic. Enthalpic meaning the enthalpy is constant. Okay, the quality of the energy. Okay, so then we also have isentropic. Okay, so it can relate because it depends on the graph. Then if the temperature is constant, we call it as a isothermal. So this when dynamic properties is constant. Meaning all this line can be even diagonal, here like this. But since one property you make it constant, so it will ease you in calculation. Okay, the state postulate. What is state postulate? The number of properties required to fix the state. So meaning if you want to make the system to be in one particular state, so you need to uh, maintain or fix the state. So you need to have a number of properties required to maintain it. The state of the simple compressible system is completely specified by two or more independent intensive properties. So meaning here you have a nitrogen gas, so you have at least two properties that can define this system. So simple compressible system is a system involves no electrical, magnetic, gravitational motion, surface tension effect. The only energy transfer by work is the volume change. When there's a compressible, so compressible meaning if you have a compressor, so you can expand or it can compress. In a simple compressible system, all these elements are not there. and the only energy transfer is related is work by volume change. That's a simple classical system. There's another term called path and also process. So what is path and process? Path means any change the system undergoes from one equilibrium state to another is known as a process. So earlier we saw equilibrium meaning so no more naturally changing condition. Meaning, if, let's say you have water, if you blow the water, it will move from one equilibrium state to another equilibrium state. Then after some time, the water will not come back to the same position. So meaning, it's already reached a equilibrium. Okay, so that is if any change the system undergoes from one equilibrium state to another state, another equilibrium position is known as a process. Meaning, earlier is already in one state, here in one equilibrium position, then I blow, then the water move to the second equilibrium process. So we call it as a process. The series of state through which system passes during the process is known as a path. So you can see here. So that's the movement of a piston. So from state 1 to state 2. Okay, so you have two properties that you're mentioning. So it can be pressure and also volume. It can be temperature, volume. It can be anything. So from state 1, it is moving to state 2. Okay, so the line in between state 1 and state 2, we call it as a path. So that is what slide is. Then we have a cycle. Okay, so cycle is another term that we always use in thermodynamics. So what is cycle? The system is said to have undergone a cycle if it return to its original state at the end of the process. Meaning you start a process. You start a process, so it goes to the part to second part, then it come back to the same form. Meaning it completed one cycle. Okay. So for a cycle, the initial and the final state are identical or same. So meaning state one actually is the beginning and also the ending of the cycle. So it shares the same time. Temperature. What is temperature? Temperature is very important thing in thermodynamics. What is the temperature? If two blocks, one warmer than the other, are brought into contact and isolated from their surrounding, they will interact thermally with changes in observable properties. When all changes in observable properties cease, the two blocks are in thermal equilibrium. So what is actually saying? So like I showed earlier, we have a mark of it, which is 70 degrees Celsius. And you just put on the table. After some time, depending on the surrounding. So let's say the surrounding is 20 degrees Celsius. After some time, the 70 degrees will be decreasing until it becomes 20. So once it becomes 20, it cannot go to 50. So once it reaches 20, it is said to reach the thermal equilibrium. So temperature is a physical property that determines whether the two objects are in thermal equilibrium. So normally temperature we are measuring to check whether it's already reached two objects already reach a thermal equilibrium. So there is another law, we call it as the zeroth law of thermodynamics. So it says that if two bodies are in thermal equilibrium with the third body, they are also thermal equilibrium with each other. Okay, so by replacing the third body with the thermometer, the zeroth law can be stated as two bodies are in thermal equilibrium if both have the same temperature reading, even if they are not in contact. Meaning you have two bodies. So one is iron, which is 150 degrees Celsius, and you have a copper, which touch each other. 150 and 20. After some time, what will happen? The highest temperature will reduce and the copper's temperature will increase because there will be transfer of heat. And after some time, maybe it will become 60 and 60. And both will become equilibrium. Both will share the same temperature. Okay, that is what zeroth law of thermodynamics is explaining. So the temperature scale. So these are the temperature scales that we normally will use. We normally will use Kelvin scale. Okay, so Kelvin. So although most of our thermometers are in Celsius because it's something that we used to. Okay, but the SI unit for temperature is Kelvin, not Celsius. Okay, so apart from Celsius, we have a Kelvin scale and also Rankine scale. Okay, so the founders and one of the first pioneers of thermodynamics. Okay, so this is the conversion scale. Okay, so you can convert from Rankine to Kelvin. You can convert from Kelvin to Celsius. You can use these formulas to, calculate. Okay, so you have some reference here. Okay, so it's easier always. Why Kelvin? Because the zero is starting from absolute zero, then it will be increasing. So meaning the steam point will reach at 373.5. And why Celsius is always used? Because the steam point we always refer at 100. But it can start from negative 273.15. So that's why if you want to convert, you need to minus Kelvin with 273.5 in order to get the same reading. And you also have a Rankine and you also have a Fahrenheit. These are some of the temperature scales that we use in here. Okay, so with that, I conclude the chapter 5. If you have any question, we can discuss in the discussion. So thank you.